Mm, See, yeah. Hello, hello, mic check, mic check. See, yeah. Hello, hello, mic check, mic check. Okay, there was some issue in the stream. That's okay. So what I was thinking of, let's start again. What I was thinking of doing this question, I should write just a brute force selection. I think that should be accepted. I don't know. Let's see. So what I will do is I will create a vector, okay, permutation, and it initially it will be of length n. Okay, so what I will do is I will just fill the permutation of I will be just I. Also, I will create a vector integer arr just as said in question. So what I will do is I will just use a do while loop, right? While arr is not equals to perm, okay, and I just return the operation. Operation will be, let's say, integer operation equals to 0. Okay, operation plus. Okay. Now what I need to do is I just need to for ti equals to 0, like I less than and I plus plus. So if I mod 2 is equals to 0, then arr of I will be nothing less than uh, permutation of I by 2, else arr of I will be permutation of n by 2, sorry, plus I minus by 2. Okay, this will be this. Okay, now after this, okay, arr, uh, but um, let's create another vector, original. This will be the original permutation. Okay, now what I will do is instead of comparing this, I will create original as this, and I will assign uh, arr to perm. That's it. Hmm. Uh, let's see, should it get accepted? I mean, n is 1000, right? So this will go on doing till I get, let's see, right? Okay, it gets accepted. I thought of this solution by looking at the acceptance rate. Okay, if acceptance rate is higher, it means this that the brute force solution will get solved. But I don't know. There should be some other solution to this, right? Let's see some other solutions of one space. Mm, recursive. Okay, let's say the permutation we are given is a bit hard to work with, and we are asked to find the order of this permutation. Let's look at an example and see what happens when we observe when n is equals to 10. So, one thing to notice is that the start and the end of the list never change. Yes. Looking at the second to last column show another pattern. 185472. It seems that the values in the column are almost divided by 2 each time. 8421. Yes. Then we get a different value. Let's dive in and see we can solve this. Hmm. There should be something else. Okay, we do the same graph. Graph? How can graph? See the graph then? You can write a brute force matrix simulation on your own, but that's not good enough for any interview. Neither will that help you understand this question in depth. Yes, that's right. Better than brute force, but still not optimal. In this matter, we are taking a graph consisting of node, okay, I values, edges from current I to new I. Okay, even then I by 2, odd, then n minus 1 plus I by 2. You can quickly see that this will form a graph like structure where each node will have only one outgoing edge and one incoming edge. Okay, 1 is 2, 2 is 4, 8 is 3, 9, 12, 6, 13. Okay. Hmm. Notice these are all loops of certain lengths. This is important because we need to come back to our original combination, and the longest length loop will help us to do this. I don't have the proof for this, but I noticed that loop containing 1 will always be the longest and will be the LCM of all other loop lengths. LCM of 1 to 4 is 4, which is our answer. Okay. Now this is something interesting. 0 says 0, 1, 2, 4, 8, 1. Okay. Hmm. Uh, that is kind of right because 0 is getting to 0. Okay. Hmm. When n is 16, where is the 16 one? I think 16 will also not change. 15, right? 15 is not okay. 15 will also not change. So 1 will get 2, 2, 4, then 8, and then again 1, and this loop will continue. 3 will continue 9, 12, 6, 3, okay. This will continue. 5 will go to 10, 5, okay. 7 will go 11, 13, 14, and 7, okay. So what this guy is doing is it is maintaining an adjacency list, right? Mm. So 0 will contain this, I is equals to 0. Mm. 1 will be here, 2. Why current is not equals to 1? Okay. Something else. What is this? I think this is same as the one solution. Okay. I don't know, but okay, let's see this one, right? Here is the solution you are waiting. Okay. In order to follow the solution, let me add more explanation meanwhile. Solution will simulate the whole array. Right? Simulation or index. Find the inverse path of I. What? Using Python to similar and interesting. Hmm. Yeah, this one I have done, right? Simulate the whole array. Simulation and index. Find the inverse path of I. What do you mean by inverse path? Inverse path. Okay, I is greater than this is O of 1. C plus plus, okay. So while result is 0 and I is greater than 1, if I is less than n by 2, it will get multiplied by 2. Okay, if else this will go plus plus. Hmm. I didn't understand the solution. Simulation or index. By checking the resultant solution, we can see that the index shift from left to right and back to the left. Take index 1 for example. Its shift path is 1, 2, 4, 8, 7, 5, 1. Okay, so this is the path, shifting path. Okay, 1, 4. Okay. In solution 2, we track one index until it back to its original position 1. For each position, its next position is. Now we get the solution jump. Okay, okay. Hmm. Shouldn't we what, do it for all I is equals to 1? Okay, so we are looking for the only one index. If it is in left part, so it will get multiplied. As if it is in right side, then it should go left, right? 8. If it is in left side, so 1, 2, 4, 8. Okay, now it is in greater side, so it will go on here, here, and then here. Hmm. Okay. Yes, that is my question. Why we are tracking only one, not only other element, and why it is necessary that if one is back at its original position, then all other element will also get back to the original position. Uh, 2 is same, any number from 1 to n minus 1 works. N minus 1 is a loop of length 1. For some n equals is an loop between 1 and maximum. I guess it involves some trial and error. During the contest, I thought of the competition of 100. is already too big to loop over. So it got to absorb patterns, but it finally turned out it was fine too. It due to certain hidden property that I don't know. There is a proof that when so plus one, that's not true. If you then you will find 3636 while the correct answer is 6. Yes, you are right about why should we calculate on 1. I till x, I mod was if I is equals to 1, then for I equals to 2 till n also valid. So 2 to the power x 1 mod n minus is a sufficient and necessary condition for this problem. Hmm. Hmm. Why 1? I multiplied by 2 to the power x equals to I mod n minus 1. Hmm. I feel anxious to do. Yeah. Hmm. Okay. Okay. Let's move to the next question. I think there is. I will look this solution a later while. Hmm. Okay. Okay. Let's reset the timer. Okay. Wait a second. Okay. Hmm. Okay. Let's start the timer. Okay. Maximum XOR for each query. Wait a second. Let me check the stream. Okay. Let's reset the timer. Okay. Wait a second. Okay. Hmm. Okay. Let's start the timer. Okay. Maximum XOR for each query. Wait a second. Let me check the stream. Okay. Let's reset the timer. Okay. Maximum XOR for each query. You are given a sorted array nums of length and integers. Okay. An integer maximum bit. You want to perform the following query n times. Okay. Find a non-negative integer k which is less than 2 to the power maximum bit. Okay. So that nums 0. Okay. The XOR of every element. XOR of k is maximized. Okay. And k is answer to the ith query. Remove the last element from the current array nums. Okay. Return an answer where answer. Okay, okay. Hmm. Okay. So maximum bit. Okay. For the ith query, I have to choose such k so that the answer get maximized, right? And what I'm doing XOR. Okay. I'm doing XOR operation. Okay. Fine. Think. Let's take the example first. 0. So binary is 0 0 0 0 8 4 2 1. Okay. 1 is 0 0 0 1, 1 is again 0 0 0 1, and the 3 is 0 0 1 1. Okay. Now maximum bit is 2. So I can choose from 0 till 4, right? Or less than 4. I can choose less than 4, right? Yeah, I can choose 3, 2, 1, or 0. Yeah. Now I'm doing XOR. Okay. Let's take the time complexity, length and 10 to the 5, maximum bit is 20. Okay. Nums is sorted. Okay. Nums is sorted. Hmm. So why they have given me a sorted array? And in every step, I am removing the last element. So I am removing the maximum element, right? Hmm. And I am doing XOR of every operation. Okay. Hmm. See, this part is everywhere. So I can pre-compute this, right? I can pre-compute this. And I need to find a k. Okay, k will be also always less than this, right? Yeah. Hmm. K will be always less than this. Okay. So that sort of that will k gets maximized. Okay. Hmm. Okay. So what I can do is, let's say I pre-computed the XOR for the length, let's say length, and the XOR comes out to be 0, 1, 0, 1, right? Now, if I want to maximize this XOR operation, I need case such that it get maximized, right? So what I will do is, it should always less than 2 to the power the maximum bit, right? Hmm. Okay, 2 to the power 2. Or what I can say, 8, 4, 2, 1, 2 to the power 2, that is 4. So maximum I can choose this bit, right? So I will start from the maximum bit -1, and I will see whether it is 0 or 1. If it is 0, then I will have a 1 here, right? And for the next, if it is 1, I will put 0 here so that it gets 1. Okay, I understood the problem. Okay, so first of all, what I need to do is, since every time I need to calculate this, I will create a prefix or error. Okay, create a nums size will be nums not size. I will create a prefix or array, prefix XOR, okay, of length and itself, and let's say initially it will be 0. Okay, let's take a XOR, or let's say for I equals to 0, I less than n, I plus plus. Okay, so prefix XOR of I, okay, will be nums of I XOR, XOR with prefix XOR with I minus 1. Correct, yes. And if I is, this should happen if I is greater than 0. Else, prefix XOR I will be just nums of I. Okay, fine. Now the pre-computation is done. So what I will do is, I need to find the maximum bit. Okay, maximum bit. Okay, fine, fine, fine. What I will do is, okay. Now I have to write for every query, right? So vector integer resultant is to, sorry, resultant, it should be of length n, and for integer I equals to 0, I less than n, I plus plus. Okay, so what I will do is, uh, for the first query, I should have a computation of this. So for ith query, I should have a permutation, sorry, the value of this and till here will be just what do you say? It will be uh, XOR will be prefix XOR of what n minus 1 minus I, right? So if I is 0, then this will become, if I is 1, so I know this element will get deleted, so n minus 2, so this will, okay. So XOR is calculated. Now what I will do is, uh, what I will do is, I will create a, let's say, I will create an bit array for this. A bit array. It will be of 32 length. Actually, let's say 0. Mm, Still don't understand why they are giving me a sorted in ascending order. Mm, let's see what I think is correct. Bit array. So what I will do is I will create a temporary variable XOR. So while temp is greater than 0, what I will do is we'll take an index also. Next will be 31. Okay. So bit array of this index will be this temperature and 1. Okay. And so temperature will now, temp will be now will decrement by 2 and index will also decrement. Okay. So now I have created the bit array. Now what I will do is, since I can manipulate from 2, right? So what I need to do, suppose there is, let's say 8421, and they are saying that it should be less than 2 to the power maximum bit, with 2. So it means I can manipulate from 2. Right? I can manipulate 2 indexes. That is 2 and 1 itself. Okay, so let's say 2. So it should be, it is 31, 30, 29. So it should be 32 minus the maximum bit. Okay. So from the bit I can, this bit from bit index will be 32 minus this maximum bit. What is maximum bit? Okay, done. Now from here onward, from integer I equals to this bit index I less than 32 I plus plus. Okay. Now I can choose any element, right? So if the bit array of this I is 1, so okay, so what I will do is I will just reverse it. So bit array of I will be not of bit array of I. Okay. Now what I need to do is I just need to calculate the value. What is the value for this? Uh, what is the value of this current query? So for integer, j equals to 31, greater than equals to 0, j minus minus. So value, what I need to do, so let's, okay, let's take a power, 0. If, let's get 1. If bit array of j is 1, and what I will do is I will implement value plus equals to power of, let's say power, okay, power will be multiplied equals to, okay, j minus minus. Okay, and for this query res of I will be this value, and in the end I will just return the resultant. Let's see. Let's see. Okay, it is giving me But stick is a long. Okay, it is getting accepted. One thing I can do is use nums of I. What is nums of I? They have not given me nums of I. Right? So let's say that's long, right? So that I don't get any error. Bit array will be 32, okay, temp, okay. Bit index will be okay. Long power as of I equals to val. Res, okay. Let's see. It and this. It should be a hmm, let's submit it. I think there should be some error. Okay, get accepted. But 5%, okay. The time complexity of my solution is what? First of all, I am pre-computing the prefix of, so it will be O of n. Then for the every query I am writing, for the every query what I am doing is I am creating a bit array of 32 length, right? Uh, temp is greater than 0. So this will be what? This will go until 32. So I into n into 32. Then again 32. Then again 32. So the time complexity will be of n into 32, right? Hmm. Okay. This is, I think, a good question. So what I have done is, I saw that there is some pre-computation. So what I did was pre-computed some this. Now I need to find a case so that this get maximized, right? So let's say the solution for this is 0101, and let's say the solution for this is 0101, right? Now I have to choose case so that this get maximized. So I know that uh, the XOR, whenever it is different, then it is 1. So if it is 0, then in my k it should be 1, and if it is 0, then in k it should be 1. So what I am calculating here, so whatever I pre-computed the value here, I am calculating the bit array for that, and for this here you can see the bit index, right? So for example, let's say my XOR operation is 0 1 1 0 1. Okay, my XOR binary is this, and let's say the maximum bit is 2, right? So 2 to the power 2 is 4, which is 0 0 1 0 0. Okay, and they are saying that it should be less than this. So I know it should be less than this is less than 4 is 3210. So I know I cannot manipulate this from here onward. I cannot manipulate this index, but I can manipulate these two index. So I'm calculating the bit index from here. So it will be 32 minus maximum bit. So 32 minus 2 will be 30. So this is 31 and this is 30. So from this onward, I can manipulate it, right? So for this operation, what will be the maximum, k, okay? So what I will do is my k will be like this, okay? Here it is 0, so I know I need to change it to 1. So my k will be, here it will be 1. So such that when doing XOR with this, it will get 1. Okay. Now here it is 1, so it will be 0. So that after XOR it is 1. So in this way I can maximize for the every query. Okay, let's move to the next question. Let me drink some water. Let's check the stream for the every query. Okay, let's move to the next question. Let me drink some water. Sorry, uh, sorry. Let's start the timer. Okay. Maximum element after decreasing and rearranging. Okay. You are given an array of positive integer array. Perform. Okay. Okay. We are given some array. Perform some operation, possibly none, on array, so that it satisfies these condition. Okay. So we have to do some operation on array so that it satisfies some condition. Those conditions are the value of the first element in array must be 1. Okay. Okay. The absolute difference between any two adjacent element must be less than or equal to 1. Okay. Okay. Fine. There are two types of operation that you can perform any number of times. Okay. So that it satisfies. Okay. There are two types of operation that you can perform any number of times. Okay. Decrease the value of element of AR to a smaller positive integer. Decrease the value of any element of AR to a smaller positive integer. Okay. Rearrange the element of AR to be in any order. Return the maximum possible value of an element in AR after performing. Return the maximum possible value of an element in AR after performing the operation to satisfy the conditions. Let's say this is AR. So this is not 1. So condition 1 is failing. So what I will do is we can arrange it. Well, there is a, okay. Now the largest element in AR is 2. Let's say largest element is 1000. What is 3? One possible way, return the maximum possible value. Okay. Oh, this condition should also satisfy it. Largest element is 3. Okay. Hmm. So, okay. So I know for sure that what the first element is 1. Okay. Okay. And what I can do is Hmm, I can reduce the element, right? So what happens if there is more than one? Hmm. If it is one, then the next element should be one or zero. It can be one. So one, one, two, 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 two. Okay. So what I will do is I will firstly sort the array, right? One, one, two, two, two. I will firstly sort the array and I will check whether the difference is less than or one. Okay. First of all, I will check whether the value in the first element must be one, right? So let's say the minimum value is three. Three, let's say four, five. Okay. So I know that I need to change it to one. So the next element will be one or two. So if I want to maximize it, I will make it two. For the next, I will make it three. Hmm. Okay. So what I'm thinking is of firstly sorting the array, and then from there onward, what I can do, I can choose to manipulate, right? See, here is the main part. They are saying that the absolute difference between any two adjacent elements should be less or equal to one. So the next element of the current element we are sitting on will be either equal to this or greater than this. Sorry, one greater than this. So if it is equal, and we can do this any number of times, right? Yes. Okay. I think the solution will be, and we cannot increase it, right? So the values, so the maximum value in our answer will be always less than the maximum element of the array itself, right? Okay. Right. Right. Oh, right. Right. Hmm. Okay. So let's say if I solve this array, then I know that array one should be always one. Okay, I made it one. Right. Then from next onward, then from what I'm saying, then from next element onward, it should be either be two or should be one. Right. If it is one, then we cannot change it. Okay. We move on to the next element. If it is three, if it is greater, then we need to change it to two. I think this in this way maybe. I'm not sure of exactly whether this solution will work. Let's see. So but firstly, what I will do is I will sort the array, arr.end. Okay. Hmm. Uh, okay. Firstly, I will sort the array. Hmm. 10 to the power array 10 to the power 9. Okay. Firstly, I will sort the array. Then what I will do is I will iterate from the tree. Okay. So I know it should be always be one. So array of I, the value of array of I is what? One. Okay. So array of 0 will always be one, right? So let's say one. Now I will iterate from the one onward. So I'm saying, okay, if array of I, sorry, it is sorted, right? So array of I minus array of I minus one. If it is less than or equal to, oh sorry, one. Okay, either what I'm saying is, let's say the 1, and the next element is 1 itself. Then 1 minus 1 will be 0. Okay, then it's fine. If it is 2, then also it is fine. So what I will do is, I will do nothing. Okay. If it is greater than 1, then what I will do, I need to reduce it. And but to reduce, array of I will be nothing but array of I minus 1 plus 1. Right? Right. And just in the end, I will just return the array of n minus 1. Last, because that will be the maximum, right? Okay, it is getting accepted. I still think there will be some case where this will fail. Where it will fail. Okay, because we cannot increase the element. Either we can rearrange or we can decrease. I think this should be fine, right? Let's submit it. I think this should be fine, but still, I think it will fail. Okay, it will passed. Hmm. Okay, the time complexity of this, my code is n login for this, and for iteration, it is n. So n login is the solution. Hmm. Okay. So what I did here was, since I know that the first element will always be 1. So whatever that is, let's say 3, 7, 8, I know that it will get reduced to the 1. Okay. Now from the first position from here onward, what I need to do is, if I need to calculate the difference of previous one. Okay. If it is less than equals to 1, then I know that it is fine, right? I cannot increase it, right? So only I can decrease it, right? And if the difference is greater than 1, so I know I need to reduce that element. And what to reduce? Previous element plus 1, because we need to maintain the absolute difference of 1. And in the last, it will be just be the last element will always be the maximum. uh, is there any other solution? Log and sorting. Greedy. Look for sort in one pass. I think fine of n complexity. Yeah, it is n log n, right? Well, they are also doing the same thing. Okay, I think this should be not be medium, right? It should be a symbol. Okay, okay, this one is good. Let's move to the next question. Single threaded CPU. Okay, let's reset the timer, check the stream. It should be a symbol. Okay, okay, this one is good. Let's move to the next question. Single thread. My code is n login for this, and for iteration, it is n. So n login is the solution. Hmm. Okay. Okay. Let's start with this. Single threaded CPU. Okay. You are given n tasks labeled from 0 to n minus 1. Okay. Represented by 2D integer array tasks, where task of I is NQ time processing time, mean that higher tasks will available to process at the NQ time. Okay. And will take this much time to finish process. You have a single threaded CPU that can process at most one task at a time. and will act in the following way. If the CPU is idle, then there are no available tasks to process. The CPU remains idle, okay. If the CPU is idle, then there are available tasks. The CPU will choose the one with the shortest processing time. If multiple tasks have the same shortest, it will choose the task with the smallest index. Okay. Once a task is started, the CPU will process the entire task without stopping. Okay. The CPU can finish a task, then start a new one instantly. Return the order in which the CPU will process the task. So, okay, wait a second. This is so I have to sort this vector based upon the sorting processor time. What is this question? This is NQ time. This is processing time. Okay, for the current time itself. 7, 10, 17, yeah, this one. Hmm. Okay, okay. So what I need to do is I need to sort this thing to 4. What? 0, 1, 2. Wait a second. At time 1, the idle CPU start processing task 0 available to task is done. At time 2, the task 1 is available to process. At time 3, task 2 is available first. Also, the CPU finishes task 0 and start processing task 2 at it is shorter. Okay, okay. So what I'm gaining from this question is the CPU will start, okay, at current time. Let's say time is 1. Okay, so I should have sorted something such that at a current time, not at a current time, but available, they are pushed, let's say priority, minimum priority, and shows them according to the right. Hmm. So let's look the first example. Okay. Right. Task is 1, 2, 2, 4, 3, 2, 4, right? Task is this much. So what I will do is, hmm, task is 1. So what I will do is, priority view, it will store the minimum, right? Because we need the shortest time. Okay. So what I will do is, till the time I is 1, so NQ time is 1, I will push all the elements in priority view. Okay, so currently now only one is pushed, that is 1, 2, 1 comma 2, right? Now I is at this one position, that is 2 comma 4, okay, because this NQ time is okay. Now what I will do is I will took the minimum one from here, that is 1 comma 2. I took this, right? I took this, okay, I took this, okay. Yes, I took this. So 1 comma 2, 1 comma 2, 1 doesn't care now. Okay, so it needs time of 2. So my CPU started from 1. Okay, it will be available in third time. Okay, now what I will do is I will increment I. I is at 2 comma 4. So its NQ time is 2. It will get pushed now. I is 3 comma 2. It will get pushed now. Okay. Hmm. Okay. 4 will not be get pushed. So first 0 will be there. Now there are two tasks in the queue. 2 comma 4 and 3 comma 2. 3 comma 2 has the shortest spanning time, so it will get popped out first. So 3 comma 2 will get finished. So current time is 3. The CPU will now be available at 6 time. Okay. So what I will do is I will push also 4 comma 1 as well. Then when at time 6 when it is available, the 4 comma 1 has shorter time. So 4 comma 1 will get accepted. So 0, 2, 3 and 1. I think this should be solution. Okay. All right, fine. So what I need to do is here, I need to create a priority queue. Okay, let's take the task as task dot size. Okay. So what I need to do is I need to create a priority queue, right? It should be of pair integer comma integer. Okay, and pair of pair greater. I'm creating main heap. Pair of integer comma integer. Correct integer. Okay. Now let's say my current time is 1, right? Okay. So also my, let's say integer index is 0. Okay. Now what I will do is hmm, for integer, let's say while index is less than n. Okay. Okay. Also I need to create a vector which will store the order. Okay. Yeah. Entry time is always greater than 1, right? Okay. Let's sort this array. It is sorted or not? Entry time of I, processing time of I. Maybe they will be in reverse order, right? Some they should have said here. Mm, let's sort the task so that they always are in order of their entry time. Okay. So my current time will be not 1, it will be task of 0 and 0. Current time will be this. Now what I will do is while index is less than n and tasks of this index 0, the entry time of this is equals to the my current time. What I will do is I will simply push. What I need to do is push since I need to sort them according to the entry time, so I will push the sorry processing time. I will push the 1 and the index because I need to have the index also. Okay. So not equals to, or let's say less than equals to. Let's say my current time is 6. So all the values less than 6 will be available to me, right? Okay, so I'm pushing the processing time and the index itself. Now, now what I will do is, mm, uh, okay, now task is pushed, right? Now I will take a minimum time. Okay, so here integer 3 will be pq dot top. Okay, so the index I will be p dot second. and the time it will take is p dot first. So my current time will now be incremented by my current time will be now be incremented by p dot first, right? Right. My current time, and I will also push back this index and order dot push back this I, right? Fine. Now my current time is incremented. Then also I will iterate on the array. In the end, when all tasks are pushed, then I should do this. I should call this. This is, and in the end, I will just return order. Let's run this. Hey, very tasks. Spelling mistake. So, pushback I semicolon. Where is the semicolon? Hmm. Case 2, this is giving me wrong. Why? Task of index of 1. So this should get priority, right? 4. Pair of integer comma integer. Wait, why? Class of class of index of 1. This is 0, this is 1. Wait. Wait a second. This should get first, then this should 3, then 2, 1, 0, then 1. But why it is pushing? So my current time, it is sorted, right? Oh, okay, I sorted the array. I think then it will be yes, shouldn't be sorting the array, right? Mm, is there a problem in this code? What happens if, let's say, this comes 2 and this come at once? What happened there? Okay, I'm getting this. What happens then? Okay, then it is giving me wrong answer. 0, output is 0, but it should be 1, 0. Hmm. Now this is the problem. Right? I need to sort them according to the uh, what I can do is I can simply just make another array of pair, sort them according to this comma with the index itself. Right? Let's do that because this can also happen, right? So I will create a vector of pair of pair of integer comma integer comma integer. Vec- Is it fine? This pair. Okay. Now what I will do is for auto ampersand vector in task. Sorry, v dot push back. But first of all, I need to sort them. This will be task. Sorry, v of 0. Oh, also I need index. Until I equals to 0, I less than n I plus v. Tasks of I 0. 0 will be the input time. Tasks I 1 will the processing time. Also, I should pass an index also. This is okay. So vector of pair. This is one pair and this is one pair. Okay. Now I can sort this. Sort v dot begin comma v dot end. Okay. Let's name this as v. So my current time will be not this. It will be v of 0 dot um, v of 0. Okay. Dot first. It will be my current time. Next, it's a 0. And instead of this, it should be v dot first. Okay. Instead of this, it will be v of index dot v of index dot second. This will be the index, and this will be v of index dot first dot second. Right. Okay. Now should be fine. I don't know. Okay. Now it is fine. Let's reset the test case. Check. Okay. Now it is getting accepted. Let's submit. I think so. Now there should not be a problem. Okay, overflow. Current time. Oh, what is the value? 10 to the power 9, of course. Of course. What do you think would have happened? Let's use this test case. Run current time. Wait a second. Why am I including current time? I don't need current, right? Let's submit. Anything else? Oh no, there is some error. Why is some error? Why is there is some error? Why PP is not empty and popping out? ISP dot second. The index is less than okay. Okay. Hmm. Okay. Oh, sorry. V dot pushback. No, this is fine. Class of I and 0. This will be okay. This will be the index. Okay. I'm sorting the V. Current time will be V of 0 dot first. That is true. Index will be what? 0. Order while index is less than n. Well, index is less than n and v of index dot first. V of index dot first. So first will be this, and first will be again the starting time. Starting time is less than equals to current time. That is fine. So I will push the enqueue time and the but v of index dot second. V of index dot second will be this I. Okay, and index plus plus. Okay. What I will do, I will pop an element. Okay. If for the current time all the elements are pushed, if for a current time all the elements are pushed, then what I will do, I will take a minimum element that will be pq dot top, p dot second. Yes, that will be the index. Current time will be added p dot first, order dot by 5. And if all the elements pushed are, all the tasks are pushed, then I will just do it. I don't know where is the error. I've sorted the tasks according to them. Okay. Let's see. The can finish task, then start one instantly. Once a task is started, the CPU will process. Okay, okay. I understood the problem. Okay. The current time is, let's say the current time is, sorry, what do you say? Let's say the current time is 5. Okay. I pushed all the 5. I took a minimum element, then okay, I understood. Here is the problem. Here is the problem. If if pq dot empty, pq is not empty, then should be true. Then this operation should fit in, right? One thing also, there is some issue here, my code, that let's say the current time is 5, okay, and I pushed all the elements, okay, less than 5, and that is fine, and still the current time gets incremented, let's say by 3, so 8. So my current time is 8. Now I need to find the task which I have NQ time of less than 8, which I have not yet pushed. But let's say the tasks are now from 10 onward, right? Then there will be issue, right? So what I will do is I need to do something here. So I will check if v of index dot first if it is greater than the current time, right? If it is greater, then current time will be nothing else than v of index dot first. I think now it should not be an issue. Use test case. Let's see. Mm, okay, now it is getting a trick. Okay, so yeah, so that will be the edge case here. Now it should be submit. Wrong answer. What the hell? 15, 14, 13, 1, 6, 3, 12. Okay, here 12, 5. Is it here? This will lead to a TLE. I knew. What I'm doing is if v of index dot first of what is greater than the current time. If v of index is first, suppose the current time is okay. If it is greater and PQ should be empty, then only I can update the this. I think now it should be fine. I can only update the current time if the PQ is empty, right? Now let's submit it. Okay, now it is getting accepted. Okay. So it was a good question. So what I did here is since I s- since I noticed firstly I noticed that they are the order of these are not in sorted order according to the NQ time. So firstly I created a vector of a pair where pair dot first is this value and the second value is the index itself. So if I sort this, then this position will get somewhere else, right? And we need the original position. So I created a vector of pair. Okay, the first pair is this one, and the second element of pair is the index itself. We have to sort this array then according to the NQ type. So firstly, it will check according to NQ type, then it will check according to the processing time, and then for the index itself. Okay, fine. Current time is the current time from where onward we will start the processing. Okay. Then while I have not passed all the index, okay. So let's ignore this part firstly. Hmm. So what I did is, let's say the current time is 3. Now if I'm starting at index 0, then what I will do is I will push back all the tasks which are less than 3, which have come in less than 3 times. I will push back in, I will push that task in what the priority queue. The priority queue is of pair where first element is the processing time and the second element is the index. Why the first element is processing time? Because we need to sort in priority queue according to the processing time and it is a min heap. So whichever has the minimum processing time, we will get that first. Okay. And also we need to have the index, right? So what I did was, if private is not empty, I will pop out the pair and I will pop out the index which is being currently executed, and I will push back in order. And since this will take whichever task has been popped out, this will take p dot first time. So I will add it to my current time. Okay, of from next index onward. Let's say there is also edge case. Let's suppose current time is 5, right? And all the process which have a less than 5 time has been pushed now, and from next index onward there are processes which have an NQ time of, let's say, 20 onward, right? So then it will be issue, right? Because current time is 5 and this is, let's say, 20. So this will never get executed. PQ will be emptied out. Okay, PQ will be emptied out. So what I need to do is, if there is a case when all the tasks previously has been executed and the current time is still less than the next task, so this is the issue case here. Okay, and then while PQ is not empty, I'm popping out the minimum processing time task and I'm adding the index of the order and I'm just returning the order. Okay, uh, let's reset the timer. Okay, okay, stream done. Adding the index of the order and I'm just returning the order. Okay, let's reset the timer. Okay, okay, stream done. Let's look at the last adding the index of the order and I'm just returning the order. Okay, let's reset the timer. Okay, okay, Let's look at the last question. Hmm. How long is the stream? 120. Start the timer. Okay. Longest substring of all vowels in order. The string is considered beautiful if it satisfies the following condition. Okay. Each of the five must appear at least once in it. Okay. So in string, each of the five English vowels should appear in it. Okay. The letter must be sorted in alphabetical order. Okay. For example, A, E, I, U are considered beautiful, but okay, are not beautiful. Okay. Even a string word consisting of English vowel written the length of longest beautiful substring of word. No substring exists written zero. We need to return the length, right? Okay. Uh, mm, I can do it in n square, but I don't think so n square will be there, right? Okay. Okay. Firstly, firstly we need to some assumption, not assumption, but let's say. So a beautiful string will be look like A-E-I-O-U, right? A-E-I-O-U. Okay. I can comes anytime. O can comes anytime. U will come anytime. Hmm. Okay. Okay. I understood the question. See, suppose let's say the string is A, E, I and A, E, I, O, U. Let's say the string is this, right? Let me write it here. Let's say the string is A, E, I, O and A, E, I, O, U, right? Okay. Let's say the string is this. Okay. Now you know the beautiful substring. What is the minimum length of beautiful substring? If all the characters are present, you know that it is of length 1, 2, 3, 4, 5, right? Right. It is of length 1, 2, 3, 4, 5. Okay. Now, what should you do? Let's say A comes two times. Okay. Now the length will be 5 plus 1, 6. Let's say E comes two times. Then will be 2 plus 2, 4, 5, 6, 7. Okay. U comes one time, 7. Okay. As you can see, firstly, we need to find whether A, E, I, O, U is present or not in same order, A, E, I, O, U, right? If it is present, then what I will do is whatever the A frequency is there, whatever E frequency is there, whatever I frequency is there, whatever O frequency is there, whatever U frequency is there, I will just add them up, right? Okay. So what I need to do is I need to create a vector. Let's say what it should be the um, should we create a pair? Let's say okay. Let's say create a pair of character and the frequency, how many time it is coming. Let's say we now what I will do is I will iterate on the array or integer. Let's say that integer n equals to word dot length th okay I plus plus mm-hmm. Okay, word length okay. Now what I will do is I will just do something else. Okay, what should I do? Okay, now while I is less than n, okay, character I am considering is character ch. Let's say it will be word of I. Okay, frequency of this will be initially 1, right? While I is less than n and word of I, sorry, word. of I is equals to ch. What I will do is I increment the I, and also I will increment the frequency. So it will be, let's say, 0. And then what I will do is create a I will push back in this vector, push back this pair, sorry, ch comma this frequency, right? Then what I will do is I will uh, for sorry, integer I equals to 0, I less than what, let's say the length of this v is len is v dot size. Okay. So let's say a e I o u 1 2 3 4 5. This is okay, and n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 5. While I is less than n minus 5, I plus plus. Okay, that's it. If sorry, if v of I, what I'm doing, v of I dot first is equals to it's a, and v of I dot that's and e I o u. Okay, if it is in this order, this should be I plus 1, this should be I plus 2, this should be I plus 3, this should be I plus 4, right? Then what is the my minimum length? I need to find the what minimum or maximum length longs, right? So sorry. So maxi len will be initially infinite. So max len will be maximum of max len itself, and b of I don't know second plus, okay, I'm just adding the frequencies of this, plus 2, I plus 3, I plus 4. Okay, fine. And in the end I will just return maximum. It should be 0, right? Return maximum. Let's say equal. What can learn? What? Why is giving me wrong answer? Case 3 is getting passed. What the hell? It is giving me 11 A E I O E A. Uh, let's do one thing. Let's see out. P of I dot first. Let me see whether this is shifting or not. Okay, let's see for this case. Okay, is one I, where comes the I comes from? Okay, so here I should be decremented by 1. No, it is being first. Okay, ln minus 5. Okay, I need to check one case, that is A E I O U. Okay, it's getting accepted. Fine. Just a bit. Okay, okay, okay. Okay, so we solved the problems. Let's check the screen. What? Okay, I thought there was two legs. How long is the length? Okay, so let's end the video here. Hmm? What do you say? There was some question here, right? Okay, this question. Okay, I will look this question and in later.